And welcome to Technology Tap. I'm Professor JRod. In this episode, we're going to talk about operating systems. Let's get to it. All right. Welcome, everyone. For those of you who don't know me, first time listening to Technology Tap, my name is Professor JRod. That's JRod, and I'm Professor of Cybersecurity. And the reason for this podcast is to help my students pass their, or any student out there, pass their CompTIA A+, Network Plus, and Security Plus. And you could, not only can you find me on this podcast, but you could also find me on TikTok. I'm at Professor JRod, that's JRod. And there I do, question and answers, quick 1-2 minute question and answer sessions. I'll do a quick, definitions and just stuff that's general for you to learn for the CompTIA exam. But it's like 1 or 2 minutes, 3 minutes the most burst. You don't want to get too many minutes on TikTok. People get bored. But I'm trying to get 1,000 likes. If I go and get 1,000 likes, I'll have the ability to go live. And, I can answer questions that you guys have about CompTIA or anything else. So make sure you look for me on TikTok at Professor JRod. All right. So today we are doing operating systems. So let's take a look. So it's different functions or core functions of the operating systems. And there's several. We might have to do this in different stages. It might not be just, it just might be a part 2. Depending how long, we last. Usually, for those of you who are new, usually I try to make the podcast between 27 to half an hour, not too much longer than that. So if I go past 28 minutes, 29 minutes, I'll stop and I can do a part 2 of core functions of operating systems. All right, so let's look at the first function, which is process management. And then process management is a fundamental aspect of operating systems that involves the creation, scheduling, execution, and termination of processes. And here's an overview. One is process creation, which includes program execution. Processes are instances of executing programs. When a program is executed, the operating system creates a new process to execute the program's instructions. Also, fork operation in Unix-like operating systems. The fork system call is used to create a new process, which is a copy of the parent process. The child process can then execute a different program using the exec system call. Next is process state. We have new. The process is being created. Ready. The process is ready to execute and is waiting for the CPU. And then running. The process is currently being executed by the CPU. Blocked or waiting. The process is waiting for an event to occur, such as user input or IO operations. And then the last is terminated. The process has finished execution. Next, we move on to process scheduling. When you're scheduling an algorithm, the operating system scheduler determines which process to execute next on the CPU. Scheduling algorithms include first come, first serve, shortest job next, round robin, priority scheduling, and multi-level queue scheduling. Next is context switching, when the scheduler switches from executing one process to another. A context switch occurs where the state of the current process is saved and the state of the next process is restored. Process synchronization and communication. Synchronization process may need to synchronize their execution to access shared resources or avoid race conditions. Synchronization mechanisms like semi-forms and monitors ensure mutual exclusive access to shared resources. Inter-process communication. Processes may communicate and exchange data with each other using IPC mechanisms or inter-process communication mechanisms such as pipes, message queues, shared memory, and sockets. Process termination. First, we start with normal termination. A process terminates after completing its execution. Only explicitly calls the exit system call. Abnormal termination. A process may terminate abnormally due to errors, exceptions, or signals. And then we have cleanup. When a process terminates, the operating system releases allocated resources, closes open files, deallocates memory to prevent resource leaks. Next, we go to process control block. The PCB structure. Each process is represented by a process control block in the operating system. The process control block contains information about the processes, including its processing ID, state, program counter, CPU registers, memory allocation, and scheduling information. PIDs, processing IDs. If you look at Task Manager from the command line, you see the PID numbers for different programs that you have open. So let's say you have Notepad open and you do Task Manager, you'll see the PID number for Notepad. Process management operations. The operating system performs various process management operations, including process creation, scheduling, context switching, synchronization, and termination based on the information stored in the PCB. Process management is a critical component of modern-day operating systems, enabling efficient multitasking, resources allocation, and coordination of concurrent activities in computing environment. Operating systems use sophisticated process management techniques to maximize CPU utilization, improve system responsiveness, and ensure reliable execution of software applications. Next, we are going to memory management. Memory management is a crucial aspect of operating systems that involves the allocation, deallocation, and organization of memory resources in the computer systems. Let's take a look at an overview. First, we look at memory hierarchy. First, we start with registers, the smallest and fastest type of memory located within the CPU, used to store data and instructions being processed. Cache, high-speed memory located between the CPU and the main memory, used to temporarily store frequently accessed data and instructions. Main memory, which is RAM, volatile memory used to store instructions and data during execution. You have secondary storage, non-volatile storage, like what? Hard drives and solid-state drives used for long-term storage. We have next main memory management unit. It's responsible for translating logical address generated by the CPU into physical address in main memory. Memory management unit perform address translation, memory protection, and memory segmentation or paging. Next, we have memory allocation, both static and dynamic. Static allocation is when memory is allocated to programs at compiled time and remains fixed throughout the program's execution. Dynamic memory is memory allocated and deallocated during the program execution as needed. Next, we have memory protection. Operating systems enforce memory protection mechanism to prevent unauthorized access to memory regions. Read-only, read-write, and execute permissions are assigned to memory pages to control access by processes. Memory protection helps prevent buffer overflows, stack smashing, and other security vulnerabilities. Next, we have virtual memory. Virtual memory allows programs to use more memory than physically available by using a combination of RAM and secondary storage. Use a little bit of your hard drive as memory. Memory pages are swapped between RAM and disk storage to accommodate the program's memory requirements. Virtual memory enables effective memory utilization, multitasking, and memory sharing among processes. And that's very, if you've never done that, it's pretty cool to see that in action. And you could always increase your virtual memory on your computer. That's very easy to do. Next is memory paging. Paging is a memory management scheme that divides physical memory into fixed size blocks called pages. Virtual memory addresses are mapped to physical memory address using page tables operated by and maintained by the operating system. Paging reduces memory fragmentation and enables efficient memory allocation and management. Then we have memory fragmentation. Fragmentation occurs when memory is allocated and deallocated in a way that leaves unused memory blocks scattered throughout the address space. Fragmentation can lead to inefficient memory usage and reduce system performance. Techniques like compaction and memory pooling are used to reduce fragmentation and improve memory utilization. Memory swapping. Memory swapping involves moving inactive or less frequent use memory pages from RAM to disk storage to free up physical memory for active process. Swapping is performed by the operating system's memory manager based on predefined swapping algorithms and memory usage patterns. Effective memory management is critical for optimizing system performance, ensuring reliable programming execution, and maintaining system stability in modern operating systems. Operating systems use a combination of memory management techniques to efficiently allocate, protect, and utilize system memory resources across diverse computing environments and workloads. File system management is the next one. File system management is a crucial component of operating systems that facilitates the organization, storage, retrieval, and manipulation of files and directories. Here's an overview. First, we start with file system concepts. Files are logical units of data stored on storage devices. They contain user data, programs, configurations, and other informations. Next, we have directories. Directories or folders are containers used to organize and group related files and other directories within a hierarchical structure. Paths are unique identifiers that specify the location of files and directories within the file system hierarchy. Like users, downloads, right? That's a path. File attributes of file systems store metadata associated with files, including file name, size, creation date, modification date, permission, and ownership. File system types is next. Disk-based file system. Disk-based file systems like NTFS for Windows, EX4 for Linux, and HFS Plus for Mac OS are optimized for storing and accessing files on the hard disk drives and solid state drives. You have your network file systems. Network file systems enable file sharing and access over the network. Examples include NFS for Unix-like systems and SMB, which is small message block, and CIFS for Windows system. And you need that small message block. You need it for more than just files. You could use it for printing also. Distributed file systems. Distributed file systems like Hadoop distributed file systems and Google file systems distribute and manage file storage across multiple servers in a distributed computing environment. Next, we have file operations, file creation and deletion. Operating systems provide APIs and system calls for creating, deleting, and managing files. Examples include open, close, create, unlinked system calls, and that's for like Unix, if you're not familiar with those. File writing and reading. File systems support read and write operations for reading data from files and writing data to files using systems calls like read and write. And then file seeking operations allow users to navigate within the files and move the file pointer to a specific position using functions like seek, find, search, right? File system organization. File allocation table, or FAT, is a simple file system structure used in older Windows systems for organizing files and directories. They use FAT and FAT32 on USBs. Master file table, MFT. NTFS uses master file table to store metadata and file systems metadata structures. INOS, Unix-like file system, use X4, uses index nodes or in nodes to represent files and directories, and store metadata associated with them. And then you have file system features, journaling. File systems like X4 and NTFS use journaling to record file systems transactions, ensuring data consistency and reliability in the event of a system crash or power failures. File compression. Some file systems support file compression techniques to reduce storage space usage and improve file transfer efficiency. Encryption. File system encryption features like BitLocker for Windows and FileVault for macOS encrypt file content to protect sensitive data from unauthorized access. And then access control list allows administrator to define granular access permission for files and directories, specifically which users or groups have read, write, or execute permissions. File system maintenance. You have file system check. It's a utility that scans and repairs file system errors, inconsistencies, and corruption to maintain data integrity and prevent data loss. Defragmentation. It's a utility that optimizes this performance by rearranging fragmented files and consolidating free space on storage drives. Standby sleep to conserve energy and extend battery power in mobile devices and laptop. Power management policies. Operating system implement power management policies to control device power states dynamically based on a system workload, user activity, and power source conditions. Device monitoring and maintenance. Device monitoring. Operating systems monitor device status, perform metrics and error conditions to detect hardware failures, driver issues, and resource conflicts. Device configurations and diagnostics. Systems, utilities, and administrator tools allow users to configure device settings, diagnose hardware problems, and perform maintenance tasks. Device security. Access control. Operating systems enforce access control policies to restrict access to sensitive devices and device resources based on user privileges and permission. Device isolation. Virtualization technologies and containerization techniques provide mechanisms to isolate and sandbox device access for security and reliability purposes. Device hot plugging and removal. Hot plugging allow users to connect and disconnect devices from the system while it's running without requiring system reboot. And hot swapping. Some systems support hot swapping device, where the device can be replaced or upgraded without interrupting system operations. Device management plays a crucial role in ensuring efficient and reliable operations of hardware devices within the operating system by abstracting hardware complexities, providing standardized interfaces, and implementing robust management and control mechanism. Operating systems enables seamless integration, and interaction between software applications and the diverse range of hardware peripherals and components. Next, we have security and access control, which are critical aspects of operating systems, ensuring that resources are protected and only authorized users or processes can access them. Here's an overview of security and access control mechanisms in operating systems. First one is user authentication. You have your login credentials. Operating systems requires users to authenticate themselves using login credentials such as username, passwords, pins, or biometric data, fingerprint, facial recognition, of the like. Multi-factor authentication, which is the big thing now, adds an extra layer of security by requiring users to provide multiple forms of identification, such as password and one-time codes sent to their mobile device. So, people talk about multi-factor authentication, and I tell my students, how long do you think multi-factor authentication has been around, right? And some people say 2 years, or some people say 5 years, some people say 10 years. It's actually been around for longer than that. It's actually been around for 40 years, I think. Because if you look at one thing that's multi-factor that's been around for years, and I'm going to tell you, you're going to be like, oh yeah, you're right. Taking money out of the ATM machine. That's multi-factor. You need the card, which is something that you have. And you need the PIN, which is something that you know. That's multi-factor. right? That's not the multi-factor like now, where they send a code to your phone, one-time code, but that is multi-factor. Taking money out of the ATM is a multi-factor that you're doing. So it's been around for a long time. All right, access control models. You have your discretionary access control, or DAC, allows users to control access to their own resources by setting permissions on files and directories. Permissions include read, write, and execute privileges for the owner, group, and others. You have mandatory access control, or MAC. MAC enforces access control policies based on a system-wide rules set by administrators. Users cannot override MAC rules, which are typically based on security labels or classifications, like secret, top secret, that sort. Then you have ACLs, access control lists. ACLs are a list of permissions attached to files and directories, specifically which users or groups have specific access rights, read, write, execute. Extended ACLs allow finer granular control by specifying access permissions for different user class, owner groups, and others, and applying additional rules based on user attributes or roles. Then you have rule-based access control, which assigns permissions to users based on their roles within their organizations. Users are assigned roles and permissions are associated with those roles. This simplifies administration and ensures consistent access control across the organization. Unless they have somebody who's special, then that messes up everything. And if you know, you know. Security policies and enforcement. Security policies, operating systems enforce security policies to govern user behavior, resource access, and system configuration. Policies define rules for password complexity, account lockout, file passwords, file permissions, and network access. Security audit. Security auditing mechanism track users' activity, system events, and access attempts to detect security breaches, policy violations, and suspicious behavior. Encryption and data protection. You have file encryption. Operating systems offer encryption features to protect sensitive data stored on disk. Encryption algorithms like AES, Advanced Encryption Standards, encrypt files and directories to prevent unauthorized access. Disk encryption, full disk encryption solutions like BitLocker for Windows and Firewall for macOS encrypt an entire disk volumes to safeguard data at rest. Firewall and network security. Firewall operating systems may include a built-in firewall, software to monitor and filter network traffic, blocking unauthorized access attempt, and malicious connections. Network security. Operating systems support network security protocols like IPsec and SSL/TLS to encrypt network communications to ensure data confidentiality and integrity. Software updates and patch management. Software updates. Operating system vendors release security patches and software updates to address vulnerabilities, bugs, and security flaws. Regular updates help mitigate security risk and protect against known threats. And then you have patch management. Patch management tools automate the process of deploying software updates and patches across distributed systems, ensuring that systems remain up to date and secure. By implementing robust security and access control mechanisms, operating systems help safeguard sensitive data, prevent unauthorized access, and mitigate security risk in computing environments. These mechanisms ensure that only authorized users and processes can access resources, protecting the confidentiality, integrity, and availability of information assets. And that's the CIA of security. So yeah, it looks like I'm going to have to make a part 2 on this operating system. But it's, I'm trying to get into the granular of the operating system so that we know, a little bit more about the operating system. People just think about operating system, they just think of Windows and, and what it can and cannot do. But they need to look at the granular of what Windows, Mac, Linux, Unix, right? What they all do. And this is what we're trying to do here at Technology Tap. So just a few housekeeping tips. I'm still doing Technology Tab Premium for those of you who want to join. It's an extra service, $5 a month. Not looking to get rich off you guys, but there are expenses to doing a podcast. I want to be able to do giveaways. I gave away. Actually, he did a nice thing. I have a winner who won the Network Plus. He won it over the summer, his Network Plus certification voucher. He actually wants me to give it away. I don't know how I'm going to do that yet, but he told me that I can give it away to anybody who he wants because he recently got his Security Plus. So he's not really interested in Network Plus, but shout out to him, my winner who won over the summer. And if anybody's interested, you know what? Let's do this. If anybody's interested in getting a free Network Plus voucher, write me an email at Professor JRod, that's JRod, and tell me why I should pick you. Why I should pick you for this, network voucher that his name is Thomas or Tomas won, and he wants to give it out. So if you think that's you, email me, professorjrod@gmail.com, and tell me why you should win. Right? You should put on the subject, why should I win, or network certification. Yeah, put network certification on the subject line. That way I make sure that it's not spam and throw it out. And then give me a compelling reason why you think you should get it. Now, if you've never studied for the Network Plus exam, don't send me an email, right? Because if you haven't studied for it, but if you study for it and you're ready to take Network Plus, and the barrier is this, you don't have the money for the certification, email me, right? I find that that's one of the biggest thing that I see. That's a very big barrier for a lot of my students is that they take the course or they study and then they tell me that they're ready, but they can't afford to buy a voucher because these vouchers they're not cheap. They're expensive. So part of the reasons why I do this podcast is in the TikTok now is I'm hoping that somebody like CompTIA notices me, and then not that I want to get sponsored for money, but I would like to get sponsored to give away, CompTIA vouchers because I think that is the number one obstacle for people getting their certification. Believe me, guys, I teach CompTIA A+ all the time, right? And I know that's I'll get, let's say 20 students to take the CompTIA, and out of the 20, there may be 12 who I think are ready to take the exam. And out of those 12, maybe one or two of them will actually take it because, they want to make sure that they're ready and they don't want to spend their money to take the exam and then fail, right? They want to make sure that they're 100% ready. And even if I tell them, look, I think you're ready, they still won't take it because they don't want to fail because they don't want to spend the money. It's a lot for them. A+ is 2 exams, like $264. That's it's over $500. So if I can get, if somebody from CompTIA ever listens to this, right, and they want to sponsor me and say, hey, we'll give you, a voucher every, I don't know, once a month or once every other month, I'll be glad to give it away. I'm not here to make, to be a millionaire, but, I'm here to help people who want to get the certifications because take it from me, I know computers change your life. I mean, I know that. IT, like any job, right? You got to be passionate about it. But I know IT changed my life. It could change your life. Moving over to academia of IT definitely changed my life. God willing, I'm only a few weeks away from being Dr. Rodriguez instead of Professor Rodriguez. But that's the story for another day, guys. I'll let you know if and when that happens. So But this is why I do this, right? I want people out there to get certified and become very successful. And it doesn't matter that you end up making more money than me. That's my big joke that I tell my students. And I won't be mad if you make more money than me. No, you can buy me a steak. I have a student who works at a famous beer distributor or beer maker, and he still owes me a case of beer because he says there's cases like when you leave the office, there's like cases right there. You can just pick it up and take it with you. So he still owes me a case. I won't say which one, but he knows who I'm talking about. I saw him recently, so he knows. But this is why I do it, guys. I do it, for you. So, that's why when you see like, oh, wait, he hasn't come out with an episode for a while. It's not that I'm slacking. I'm doing other things, doing my dissertation now. So that took up a lot of my time. But, as long as I'm around, I'm going to still try to do this podcast. And I hope and pray that somebody recognizes me and recognize what I'm trying to do here and, believes in this, what we're doing and agrees to sponsor me. But anyway, next time we'll do part 2 on operating systems. I'm looking at my notes. It's a lot. So might either do part 2 or maybe even a part 3 on operating systems. But until next time, we'll see you. This has been a production of Little Chacha Productions, art by Sarah, music by Joe Kim. If you'd like to reach me, you can reach me at Professor JRod, JRod @gmail.com. I'm also on Instagram at Professor JRod, and I'm also now on TikTok at Professor JRod. That's JROD.